Welcome to this explainer. Okay, think about the last time you missed a train just because you were stuck behind someone fumbling with a crumpled paper ticket. We've all been there, right? Well, today we're looking at how to end that frustration forever. We are breaking down the Titan AI platform and exploring exactly how artificial intelligence is transforming legacy physical rail infrastructure into completely seamless digital experiences. So if you're interested in the intersection of enterprise software and physical infrastructure, you are absolutely in the right place.
Okay, let's dive into this. We really have to ask, why on earth are our rail stations still relying on paper tickets and manual checks? It's a system literally designed for a completely different century, yet we're still using it to board state-of-the-art high-speed trains. It doesn't make sense. So let's examine how transit systems are finally solving this massive legacy boarding problem.
Here is a quick look at our roadmap for today. We'll start with the legacy boarding problem, then walk through booking a biometric ticket and look at frictionless gate access. After that, we'll cover the AI executive dashboard, edge hardware integration, and finally, wrap up with a smart station future.
All right, Section 1, the legacy boarding problem, focusing specifically on bottlenecks and fraud. Listen, every transit executive today is wrestling with these core issues. The old way of manual ticket checking, it inevitably causes severe delays and massive station congestion, especially during rush hour. Plus, those basic QR-only tickets can be screenshotted, shared, or spoofed so easily. Stations are essentially running blind. Now contrast that with the Titan way. We're moving to biometric access and automated flow, utilizing live face matches. This allows for incredibly rapid throughput, drastically reduces ticket fraud, and actually gives operators real-time analytics. It's a total game changer.
Moving right along to Section 2, booking a biometric ticket and what the actual passenger journey looks like.
So to really understand this system, we need to trace the data through this seamless pipeline. It begins, of course, with the customer booking a ticket on their device. But step 2, the processing, is where the magic happens. The second that booking occurs, the system automatically creates a database record, generates the tickets, updates the station dashboard, stores the biometric face profile, and readies the edge compute node. It's all of this heavy lifting happening quietly in the background that makes step 3, the actual boarding, completely instant and automated. The journey starts right on a super familiar consumer-facing booking interface. The passenger selects their route. In this specific demo, we're looking at Washington, D.C. to New York Penn Station on the Acela Express. They pick their date, set their ticket class to business, and review the fare summary. You know, it's exactly the kind of intuitive, everyday booking screen we all already use on our phones.
Once everything is confirmed, the system generates a modern digital e-ticket. So the crucial point here is that little tag right at the bottom, Titan BioGate enabled. This explicit label tells the passenger that biometric face recognition is active and ready to go. It means no paper ticket and absolutely no fumbling around for a barcode when you actually get to the physical gate.
Now, to activate that frictionless boarding, the passenger goes through a really quick, secure face enrollment process. The system captures a live biometric map of their face, which is then securely compared against a stored government ID. By doing this, the passenger's physical face effectively becomes their digital boarding pass. How cool is that? Which brings us to Section 3, frictionless gate access, and the handoff from software to the real world. And this brilliantly illustrates the whole concept in action. When the passenger arrives, they don't stop to talk to staff. They just look at the terminal. The verification engine instantly cross-references the ticket validity with a live face scan. Notice that access approved status, highlighting a 98.7% live biometric match in a fraction of a second. It verified the ID, validated the QR status, and matched the train time, instantly triggering the physical gate to swing open. Okay, let's pull back a bit for Section 4, the AI executive dashboard. Zooming out to the macro view. You see, this software isn't just a basic ticketing app. It's a comprehensive AI operations platform. Look at the macro data a station manager gets instantly. We're talking 12,480 passengers today. But even more importantly, the AI actually forecasts passenger volume. Here, it's flagging a peak congestion bottleneck expected at 5:30 p.m. at Penn Station, and it's automatically recommending that 6 gates need to be open to handle the flow. It's literally spotting and solving traffic jams before they even happen. And the sheer operational efficiency of the system becomes so clear when we look at this approval ratio. Out of thousands of entries, we see 11,920 approved, just seamlessly flowing through the gates. And there are just 84 denied attempts. This means transit staff are no longer manually checking 12,000 tickets all day. They only need to step in and handle those 84 flagged attempts that actually require a human touch. Because of that incredible efficiency, we arrive at a massive, absolute game changer of a business metric: 35%. Automating the boarding process and shifting staff away from manual ticket checks creates an estimated 35% in daily labor savings for the Transit Authority. I mean, that is a staggering return on investment for a single infrastructure upgrade.
All right, Section 5, Edge Hardware Integration, where the software actually meets the physical hardware.
Now, here's the real brilliance of Titan AI. It doesn't force a transit system to do a massive, expensive rip and replace of all their physical gates. Instead, it acts as a central brain, a digital twin modernization layer. It is compatible with a huge array of commercial hardware: turnstile gates, flat barriers, face recognition terminals, standard QR code readers, RFID scanners, and relay controllers. It scales by intelligently integrating with the hardware that's already bolted to the floor. It pulls this off through a vital piece of local architecture called the Titan Edge Gateway. Look at the latency metric here, 42 milliseconds. To put that into perspective, a human eye blinks in about 300 milliseconds. So this local edge gateway ensures physical turnstiles keep operating with rapid 42 millisecond latency, acting completely independently of the cloud. If the station's internet goes down, no problem. The gates keep opening and closing based entirely on that local edge compute. Let's move to and see how this builds out for the technical stakeholders. This simulated API panel shows exactly how the Titan platform triggers those physical actions. It uses straightforward, highly standardized API endpoints. You can see post requests like /API/gates/A1/open, or simple commands to check device health. It makes it incredibly straightforward for integrators to wire up the AI software layer to pretty much any brand of physical gate controller out there. And finally, Section 6, the Smart Station Future, viewing this as a complete modernization layer. Ultimately, this whole platform is meant to be a comprehensive enterprise modernization layer. Taking a peek at the Phase 2 AI features menu really shows where this is heading next. Because beyond just opening gates, Titan introduces the Victoria AI Assistant to act as a virtual station concierge for voice requests, alongside real-time fraud monitoring and recovery flows. It completely transforms what used to be dumb, physical metal gates into highly intelligent, data-driven checkpoints. Which leaves us with this final thought. We've seen how AI can turn a passenger's face into a secure ticket, clear congestion before it even happens, and integrate directly with existing legacy hardware to save an estimated 35% in labor. So the big question is, how much could your transit network save by upgrading dumb physical gates into intelligent, AI-driven checkpoints? Thank you so much for joining me for this explainer. I hope this really helped you better understand the infrastructure powering the future of travel.